Hi. So today we're going to work on 10.3 and simplifying radical expressions. But first, let's recall what we did in the previous section, and that was just learning the rules of rational exponents. So very quickly, we're just going to go over the two, and they were just that this pen, you might have to redo that. That pen is gross. All right, so that is a to 1 over n can be rewritten as the nth root of a, and that's it. The second part of that is if we had a different number or letter there instead, and then that would be the nth root of a to the m, or more likely than not, we write it as the nth root of a to the m. All right, so with that being said, now we're just going to take all the skills that we have learned and combine them into simplifying radical expressions. So I'm just going to give some examples and we're going to plow through them. So some quick ones are, if we had 49 to the 1/2, that's just asking us to take the square root of 49, which we know is 7. So that's working backwards from, well, I guess not backwards, it is the rule, from here to the radical to there. Then we can also do, let's do 1/64 to the half. And our rules of radicals say that that is the square root then of 1 over 64. And we can split that up into two different parts, the numerator and the denominator. And so the square root of 1 is 1, and the square root of 64 is 8. So these are ways that are pretty simple to show you the examples of using radical expressions in a simpler form. So now let's get a little crazy. Let's make this a little harder and see why it would be useful to know these rules. For instance, if we had 3x to the 4th, or 1/4, all divided by x to the 1/2, we need to notice that we have the same bases here with x's, and we're going to use the rules of exponents to just deal with the fractions the way they are. So we know that 1/2 is greater than 1/4, and we're going to just, because we have the division, we're going to move that down there and use the subtraction. So that's going to be 3. We have the same base of x, and now we have the 1/2 minus 1/4, and we need to have a common denominator. Most of us that bake or cook kind of know these fractions, so I'm going to skip that a little bit. And we know if 1/2 minus 1/4 cup still gives us 1/4 cup. So we can write it like that. If you want to get fancy, you can rewrite it as 3 over the 4th root of x, but we don't usually write it that way. We would write it more this way. Another example, super crazy, really nuts, we're going to add a bunch of rules all together, is going to be this one. M squared times n all to the 1/4 power divided by m to a negative 1/2, that should be a 1 there, n to the 5/8. That's crazy. We have a lot of things going on there, but our same rules apply. We're just going to take it piece by piece. So our rules of exponents say if we have an outer, we're going to distribute them through and multiply exponents together. So our top becomes m squared times 1/4, n times 1/4, and we also have a negative exponent down here. That rule tells us that that negative exponent then needs to become a positive by moving it from either the denominator to the numerator or the numerator to the denominator, depending where the negative is. So because our negative exponent's in the denominator, we're going to move it up to the numerator. So that will be m to the 1/2, and it's all over our last piece here, which is n to the 5/8. Well, we've rearranged it. It still looks pretty messy. So now we're going to do what it tells us to do and combine things where we know we can combine using those rules. So if we say 2 times 1/4, we know that that's m to the 2/4. And I'm going to go ahead and put this m next to it so it cleans it up a little bit better. And then now we have n to the 1/4 and n to the 5/8. Some of you might have already seen it. If you don't, we can reduce this fraction. And then we would add them together because we have the same base. So this becomes m to the 1/2 plus the 1/2. We still have our n to the 1/4 all over n to the 5/8. When we're getting simpler, it's not looking nearly as scary. Let's just keep going. 1/2 and 1/2 is 1 whole. We're going to just write m. And now we need to see which one is bigger, so we know to either add or subtract. 5/8 is greater than 1/4, so we're going to subtract that 1/4 from the 5/8. So now we'll have n 5/8 minus 1/4. Again, we need a common denominator, and we'll end up with m. I hope you can read this down low. 5/8 minus, well, to get an 8 as our common denominator, that would be 2/8. And we're super close. We just rewrite the last little bit. We have n to the 3/8. So something as crazy as this, using all our rules, can come simple as that. So what is the point of doing all this? Why do we even bother to simplify? These are just expressions, meaning we don't have any equations to them. But we can have equations that have pieces that are just as ugly. We'll know how to simplify them to make our equation easier to solve for whatever variable we need. That's the big picture. So there's one other section that we can do with these rules, and that would be we can still factor with these fractional exponents or radicals, or we can distribute. We're just going to show a little bit of examples for those, and then we'll be done with this section. So let's try y to the 1/2, parenthesis, y to the 1/2 minus y to the 2/3. Well, our first order of precedence or order of operations would be to simplify inside the parentheses first. However, these are not multiplied together, so we can't do anything with these exponents. Those exponential rules will trump doing that parenthesis. So this is as simple as this expression gets. The only thing we can do now is distribute this y to the 1/2 to both sections. So we do that by adding those exponential fractions. So we'll have this 1/2 plus that 1/2. And that takes care of these two together. Our minus sign comes down, and now we have the 2/3, and we're going to distribute him plus that 1/2. Well, 1/2 cup and 1/2 cup is a whole cup, so we go ahead and keep the y to the first power. We don't need to write the 1. We need that common denominator again with fractions. So our lowest common denominator would be 6. In order to do that, we get the 4/6 plus the 3/6, and we end up with y minus y to the 7/6. Well, we can get fancy if we want. This is perfect enough just like it is, but we can get fancy and rewrite it as y to the 6th root of y to the 7th. That one's kind of uglier though. So while it's mathematically correct, we can end there. All right, so that's distributing, that was a fun word. So let's factor. So factor is just like we would with greatest common factors anyway, or greatest common multiples. We're going to go ahead and do this with a fraction. It's not as hard as you might think. So let's try x to the 5/2 plus x to the 3/2. Well, remember I said that we couldn't actually add these together because we have an addition sign here, so we're not multiplying. But I can factor out something that's common, and you're going to want to factor out the highest fraction that's common in both. Well, 5 is bigger than 2, so I know, 3. So I know that 3/2 can come out of 5/2. Seems a little difficult, but let's just play with it. So if I'm going to take out x to the 3/2, I'm going to leave him for a minute, and I'm going to have plus 1, because if I divide him by itself, I just get 1. And if I'm going to take away 3/2, well, let's just do that in fractional form. We'll just take it away. So we're just taking that 3/2 away from the 5/2, and we're going to see what we're left with. We've now factored out this x to the 3/2. We now have x to the 2/2. That's kind of funny looking. Let's simplify him to what it's actually saying. And we're left with x plus 1. There you have it. See you next time.